Hi everyone, so in this video I'm going to talk about a new sorting algorithm, which is basically a cyclic sort algorithm. Here in this video I'm going to do two methods of cyclic sort algorithms. One is the like easy one, and which is basically very straightforward, and the other one is the something different. Like both have a different time complexities. One is a quadratic, other one has a linear time complexity. Okay, so we'll discuss both of the methods. First of all, we discuss the easy one, and then we discuss the hard one, like not that kind of hard, but something to be understand. Okay, so that is saying, like other videos, if you didn't watch the other sorting algorithm videos like the counting short, bubble short, selection short, insertion short, merge short, quick short, I already done those videos, so you can prefer to the my sorting algorithms playlist, and you can like watch all the videos from there, and then you can come back to the this video, or you can genuinely or you can continue to this also, because those concepts and this concept are not interrelated. Just you have to have the basic idea what is shorting is. Of course, you know it is like ordering the limits in ascending or descending order, right? So that is the thing. So first of all, I will explain the code, explain the the concept of the cyclic sort, the method one, and then I will discuss the and then code it, and then I will again come back and discuss the time complexity, and then it again explain the method two, code it, explain the time complexity of it. Okay, that's the whole video. Maybe it can take quite long in this video, so uh, stay with me till the end. So let's get started. So now to talk about the cyclic sort. Okay, let's talk about cyclic sort. Cyclic sort. Cyclic sort method one. Cyclic sort method one is quite simple. It generally works. First of all, I will tell you where it works, where it can be worked. So it works only in the list where the list is generally from a range 0 to n. Okay, 0 to n, 0 to n, or any specified link, or any specific range. Suppose to from a to B. Okay, it should be any specific range, and all the elements in the range should be present there. So that means, if it is 1, 2, 3, 4, 5, that is done. You cannot skip. You cannot skip one. You cannot say it is 1, 2, 3, 5 short with element. No, in this case, cyclic sort method one, you cannot say that. If it is in a range, all the like values in that range should lie in the cyclic sort. Okay, so cyclic sort method one. Cyclic sort method two is something different. You can put any values in that there. I'll discuss that later in this video. But for now, understand it will only like work cyclic sort method one in in a specific range, in some specific range, and 0 to n is mostly preferred, but it can be a to n, a to b also. Like we'll discuss how that could be done. Okay, that's the simple thing you can say. Cyclic sort. So let's understand how it works. This is the condition. This is the condition for cyclic. This is basically the condition of range. Okay. So it is any integer. Any. This is any integer. Here we are any integers, but all the values should lie. Like it should be 1 to 4, 5. Like if it is 1 to 4, 5, so it should be this one. But if it is 4 to 10, it is 4 to 10, then it will be 4, like 4, 5, 6, 7, 8, 9, 10. You cannot skip any values between these two range. Between the first four, between 4 and 10. Okay, so that's the method one. Okay, that's the method one. So let's explain step by step how this works. How to short it is the I discussed the condition. Now let's talk about how it works. Like how it works. Let's talk about. Okay, yeah, yeah, how it works. How it works. Okay, how it works. So it is quite simple. Suppose you have a list. Suppose 2, 1, the between 1 and 5. You have list between 1 and 5. Okay, so suppose 2, 1, 3, 4 and 5. It has all the values. Like it has all the. It is of course. Okay, let's change something. Let's make some more like unorderedness here. So it is the basically not shorted list. It is an unordered list, right? It is an unordered list between the range 1 and 5, and the list contains all the elements between 1 and 5. Okay, so now in this case we know an array like array index starts from 0 to n minus 1, right? So its index is 0, 1, 2, 3, and 4, right? It ends as 0, 1, 2, 3, and 4. So now what you have to do, it is very simple. What we have to do, we take the first element. First of all, we take the first element, and what we will do, since we are starting with, in this case we're starting with 1 3 4 from 1, so to put this element in a correct place, put in so what is the correct order of it? If you short it, what is the correct order? Correct order would be 1 2 3 4 and 5, right? So where 2 lies here, 2 lies in the one index, like the index is 1 but 2 is like, but the value is 2. So what we can do in the cyclic sort method 1, we can generally, what like value we take, we just have to do -1 of it, do -1, because starting from 1, right? Because it is starting from 1, so you just have to do -1 from it, just have to do -1 from it. So if you do -1, 2 minus 1, it will give us 1. So we have to put the 2 in index 1, or we have to swap index 1, swap the value of index 1 with index, like the current index, so it's basically 0. That means we have to swap this 2. If we have this 2, so what will happen, it'll now the new list will become 1 2 3 5 and 4, right? It will become 1 2 3 5 4. Again we'll start from 1, like this one only. When I will go to the next item, when we will see that the like here is 1, right? 1. So now 1 minus 1 is 0. Now 0th index is 0. This one, it has already 1 in it. When we get this condition, like where we are inserting, where we're checking what index we're getting here after taking the minus of it, okay, the minus of it, what value we're getting, if that index contains the same value, that means it is the same value, that means we're checking for 1, and after like they are doing the minus, we're getting 0, and in the 0th index we have 1 only. After getting this, we'll go to the next index. That means after this we also have the same pair of values, this one. Now we'll go to the next index, this one. It will again check 2 minus 1, like this one, 2 minus 1 1, so 1 contains 2 only, so we'll go to the next element, and next step. So it will be 1 2 3 5 and 4 again, 3, so 3 minus 1 equal to 2, and second index is already containing 3 only, that means it again go the next element. So it will be 1 2 3 5 and 4. So it will be this one, this index. So now this index, like 5, like the 5 value, if you do the 5 minus 1, it will give you 4, and the fourth index, this one, fourth index is not containing 4, so you have to swap it with the fourth index. That means this index will be swapped with the fourth index. Now we'll get this one, and this one will get 1 2 3 4 and 5. And of course, since it is the last index, like okay, again we'll check here. We'll check if is it okay. Is it, yeah, it is okay. Like 4 minus 1 is 3, and 3 also contains 4, and so then it goes here. Is it okay? Yeah, it's okay. So that is and now it is sorted. See, it is sorted. So this is simple. There is like a simple sorting algorithm. After that, like after this, I will also explain its space and time complexity. So in that case, you will get to know how efficient it is. But it is not. It can't be work in every case. It will only work when you have a range from 1 to 5 only. Okay, it cannot work in every case, but the method too can work in every case. But in a small range. I'll discuss that in a bit. So that's the cyclic sort method 1. That's simple. That's very simple. If you didn't understand it, just just go to the back, go some seconds back or the minutes back, and see it again. You will understand because it's not that difficult. If you already understand the previous sorting algorithm, then it will be definitely it will be easier for you. So that's it. So let's now explain okay, the time complexity of the cyclic sort method one. So time complexity. Let's explain the time complexity. Okay, the time complexity. So if the time complexity, what is happening actually? What is happening? We are traversing through the n steps only. What are we doing? We are traversing the n steps only. We are not doing anything else. Like uh, if we have a list, suppose this one is the list. So we are traveling through the each element. Maybe in one position it is staying for longer, but after that it is not taking that much step, right? So it is actually n. It is actually n. Because it is traversing through the each element, nothing extra. Since we can say since it is traversing through through each element each element in the array, or you can say in the list. So its time complexity its time complexity is equal to you can say big O of n. You can say big O of n, not extra. And if it's about the space complexity, it is like straightforward. If you see the my previous videos, though I not covered time and space complexity, I'll cover it later. But for now, of course, if you see my previous videos, so you'll understand, since we are not using any auxiliary spaces or extra spaces here, like temporary spaces, so its space complexity will become constant, like big O of n, big O of 1, constant. Is the linear time complexity, and it is the constant space complexity. Okay, so that's the whole explanation of the cyclic sort method 1. So now let's code it in the applet and see how it works. That'd be great. So let's jump into that. Okay, here we are in the applet, and now let's go to the CodaGo folder, and let's go to the sorting folder, and let's make a applet here, which is basically of the programming language Java. Okay, Java, and here we are genuinely like making a cyclic sort method one, right? So it will be cyclic sort. You can do it like this: cyclic sort method one, method one. Okay, cyclic sort method one. So create the REPL. Yeah, this is the REPL here. Cyclic sort method one which has a time complexity of like the linear time complexity, and the other one, the method 2, has a complexity of quadratic, like n square. Okay, so let's talk about it first of all. So if it's about let's make a function first of all. So let's static void, and void sorry it end okay, it's not required. uh, okay, it is cyclic sort, and we're taking the input as the array which we have to sort, and just we are checking it. Remember, you should have a range, and all the values should lie between this. The constants, right? So let's get the constants. Constant for this constraints, uh, it should contain the values in a range from a to b a to b uh, and also all the values, and also all the values in that range, in that particular range, with a constant actually, nothing else. Okay, so what do we have to do? uh, we have this, right? So what do we do? We have to traverse generally. First of all, I'm doing, okay, let's see, let's explain another concept first of all, then it'll be more easier for you. Why were like here in the previous case, why we're minusing 1 here? we're minusing 1 here because since our index in array starts from 0 and our range starts from 1, we have to minus 1. And in another case, suppose we have a like list which start from 3 to suppose 8. Okay, 3 to 8. So is in this case also we minus it by like 1. If we can do that? No, we cannot do that. What we have to do, we have to check what is the smallest value in the list. The range is 3, right? We'll check what the smallest value is 3. We have to minus 3 in this case. Since it is small value is 1, so in that case we minus 1. Okay, its smallest value is 3, so we have to minus 3 here. Got the thing, right? Since we are doing this because the we know the array starts from 0, so if we do 3 minus 3, we'll get 0 actually. And since it's like number of elements it here is 8 minus like 8 minus 3 plus 1, you can say it is a 5 elements here, and in this case also we have 5 elements. Okay, like it is 5 minus 1 plus 1, cancel out is 5, and here also 2. Okay, so 3 4 5, it is 4 elements, I guess. 3 4 5 6 7 8. Okay, it is 6 elements. Yeah, it is 6 elements, not 5 elements, it's 6 elements. So 8 minus 3, it gives the index, this index will be 5. Of course 8 minus 3, and last index will be 5 only. So this is the case actually. So what we do, we have to find, first of all, find the smallest element, and we have to go. In that case, we can take any range, but you have to don't want to do this, then it would be difficult for you, because that would be, in that case, that you can only go for some specific one, like it can be 0 to n, it can be 1 to n. You have to like previously you have to specify that would be like a the constant one, like constant range would be there. The starting range, starting value would be constant in that case. But in this case, you can a to b, and a can be an integer, b can be an integer. What we are doing. So first of all, uh, take the smallest value. Like get the smallest value from the list, from the array, So let's take an integer, which is basically you can say smallest, and we'll say error of 0 we are putting here for comparison purposes, and we're doing here I equal to 1, which is already taking 0, and we'll error dot length, and it will do I plus plus, and we got it. Now let us make the comparison. If okay, if the smallest value is basically greater, there is another smallest value, you can say, then what we do, smallest is equal to error of I. Okay, so that's the simple thing. We got our smallest value. Now uh, now let's sort it by cyclic sort method 1. Now again we have to like traverse it from int I equal to 0, is less than error dot length, and it will be I plus plus. Okay, yeah, I plus plus, and now what have to do, what value we're getting, like where we are, we have to minus it and check that value. Like if the current value if the current value what we have, no, we don't have to do that. What we do, if we have the what are we checking actually, what are we checking, uh, uh, so if error of I, whatever ith value we have, two value, is not equal to, not equal to error of uh, error of I minus smallest, So what we do, we just have to change it, like we have to change it like error of I minus the smallest and is equal to error of I, right? And if it is not, if it is basically equal, then what we could do, we just have to I plus plus here. We don't need I plus plus here, move it. Okay, so that's the case. So we're checking if error of I, this one error of I, that means this value, this is the error of I, right? Error of I, this 2 value. If error of I is not equal to error of I minus smallest, this is the error of I minus smallest value. This is the index, that's 1, and we're referring here again, that means it would be in the error as index. We're checking if this one value, like this one and this one, is if these two value are not equal, then both are unique, then we'll insert it there, otherwise that means we insert it there. Otherwise if it is unique, that means 1, suppose 1 is 0 and 0 index, what we get, and its value, what its value is 1, its value is 1, and that value is also 1, that means its value is 1, get 1, and previous, like that means error of ij is equal to like this one, this right hand side, so it will increase. Now since it is equal, both the cases it is equal, so it is increased. Since this is also equal, it is increased. This condition is I plus plus. And the case in this cyclic sort method 1, it cannot contain duplicate values. Do remember that, okay? Remember that. So now let's print it. Let's pass the array first of all, and like a new int, and here you're passing like suppose you're passing 2 1 3 5 4. Yeah, it's 2 1 3 5 and 4. Okay, so suppose you're passing it, and now in this case let's pass first of all this cycle short, you can say, and you are just passing the ARR, and it's printing the result, and here in this case 4, just print the result, print equal to 0, I is less than error dot length, and here's I plus plus, and just print it with the system dot out dot print, print, and you're doing error of I, and here we're just doing it. Okay, so let's run it, and yeah, recording error here. Yeah, we didn't give a semicolon, that's a common mistake. Yeah, it should be short now. 22355. What's wrong with it? We got a smallest element, right? Error dot length. Yeah, it's fine. We're doing error dot length I minus smallest, and okay, at the last I guess we have to change something. Not really, I guess. Error dot length. It should be fine. Should be fine, I guess. What's wrong with it? Method 1. Oh, what's wrong with it? The smallest value is the smallest, print the smallest value is but out of print ln smallest value is smallest, okay, smallest, and let's run it. So which one? Yeah, so this one. So then it take first of all 2 2 1 3 5 4. Yeah, it is in the range also. It will be 2 minus 1. 2 minus 1, we'll put in 2. Okay, okay, it should be swap it. I just assigned the value. It should swap. I said it's swap now, so it should swap it. That means we take a temporary variable and we'll assign it to, yeah, just and the silly mistake. It's a bigger one actually, and minus smallest, smallest, yeah, and error of I minus smallest equal to uh, error of I, and you can say error of I is equal to temp. Just swap it. That in the previous case we just assigned it, so that's why it didn't work. Now it should work. Yeah, 1 2 3 4 5. Now if you give any other range, like was it 3 to 8, right? So 3 4 5 6 7, and suppose we're giving here 8. Okay, so we're giving here 8, and yeah, let's run it, and it should give me the correct result. Yeah, 3 4 5 6 7 8. That's the cyclic sort, and it has a time complexity. It has a time complexity. Writing it, time complexity for reference is of big O of n, and space complexity of space complexity, and it will be big O of 1. Okay, like it is a constant space complexity. So that's the code for cyclic sort. Now let's jump into the cyclic sort method 2. Like, hope you understand it, right? If you didn't understand it, just go to the previous minutes and just watch it again. But now I have to go to the cyclic sort method 2. Okay, so let's jump into that. Let's explain that. Oh, sorry. Let's explain that. Okay, yeah. So let's explain the cyclic sort method 2. Okay. Yeah. Cyclic sort method 2. Where's my pen? Yeah, this one. So now let's talk about cyclic sort, cyclic sort method 2. Cyclic sort method 2. Let's talk cyclic sort method 2. So in case of the cyclic sort method 2, like there's no range, there's no specific range, but the list should be small. It cannot work efficiently for the larger items, for the larger values, right? For the larger number of larger number of list. Okay, now basically larger number of items in a list. So how cyclic sort works, that is quite simple, you can say, but for some people it can be also tedious also. So let's first explain the code. First explain the how it works, then I will do the code. Before that I will also explain the time complexity of it. So let's jump into it. So it is simple. So in cyclic sort, what we do, we just part the whole list in some sort of cycles, and thus it will give you give the sorted list in a minimum number of memory writes. That's the advantage of, you can say, the cyclic sort. It will do it in minimum swaps, and I will also give you how many swaps it do for a list. It is actually very efficient. So let's jump into it. Let's jump into it. So let's jump into it. So we have a list 2 2 5 1 and 3. Suppose this one we have a list. It is a random list, but it is something special. I already decided I will take this example because here you can get all the things, like because there is also duplicate values, and also the list is something different. Okay, so let's explain it first. So what we do in the cyclic sort, let's write first of all its index. It is 0 1 2 3 and 4, right? Its index values. So now we'll take the first element. In this case we'll take the first element. We'll take the first element, and we'll compare it with the the rest of elements, like rest of elements after the current element, and we'll take a position variable here. We'll take a position variable. Now the position is actually 0. This one is 0. Now the position is 0. So what we'll do, we'll check how many elements we have in the right side of the current value, that means this one, right, this one. In this list, in this particular sub list, you can say how many elements we have which is lesser than the current one. It's lesser than the current one. Which is lesser than the current one. We have one element, this is the current one, right? The position value will be now 1. The position's value will be now updated to 1. If we have 2, like here's 1 and another one, we have 2, so position value would be 2 then. We'll check that, right? And then what to do? We just have to this one element, right? Now I have to check if this is the one element. It will refer to this index, the second index, right? This index. So we'll check is if its value. Its value is what? 2. If it is equal to the item's value, is it equal, right? That means it's a duplicate value. In that case also, the position will be updated to 1. Like it will be incremented. Position will be incremented to. In that case also, position will be incremented to. Like incremented to means plus 1 will happen. Now now the position will refer to the this index, the third index, that is index number 2. Now what will happen? It will just do the fifth like the fifth index will be assigned in the first index. The current index will be assigned in the first index, the current index, and sorry, the second index, like the 2. We are positioning the current index, right? So 2 will be assigned in 5, and the current index, like the items value, first of all item value is 2, right? Now the item value will be changed to 5. That means it will be like 2 2. Okay, let's write in black. It will be 2 2 2 1 and 3. 1 and 3, and maybe you have something in your mind where the 5 gone. 5 is there. 5 is stored in the item variable. It is there. Now in that iteration only, in that particular iteration only, we'll check again the same logic. We'll check again the same logic that that's a 5 value. We have a 5 value, right? And the position will be start from here again, and this one will check if this particular sublist, if this particular sublist has some elements which is smaller than this item, it has there's 4 elements, right? 4 elements. So the new positions index will be 4, right? New positions will be 4. Now it will again check the same thing. Is like is this like is the fourth index contain a value which like contain a duplicate value? So it will no, it is 3. It is not a duplicate. It is not 5. It's 3, right? So so in that case we can update it. Like the 5 value can be here. 5 value we can put it here. 5 value here, and whatever is there, like 3 is there, right? So 3 value can be put it here. 3 value can be put it here. Now after 2 3. So it's 2 2 1 2 2 2 1 and 5. Now 3 is there. Now I'll again check again. So 3 is there, right? Now in that iteration only we'll check. We'll again have the new again start from position equal to 0, and start from position equal to 0, and it again check in this list only, this sub list only, that is there's some elements which is lesser than 3. There are 3 elements, that means position would be updated to 3. Now I'll check if the third index value is equal to the items value. No, it is not. So position the position value didn't increment like this, this what happens here, right? So it didn't increment it, and it will assign the third index value 1 to 3, and items value will be updated to 1. That means it will be updated to 3, and items value would be updated to 1. Okay, now item value will be updated to 1. Now we'll check if one's value, like one value would like it can start from 0. It will again start from 0, and it'll check if like one value, like if there is any elements which has lesser than 1. No, it don't have an element. That means position will remain 0, and it will say if 0th element element's value is equal to the item's value. No, it is not. It is 2. It is 1. It is not equal. So now just we have to put item here like 0, like here should be, we can cut it, and it should be 1. So it will be 1 2 2 3 5. Just see, it is just happened, it is just shorted in one particular, like by taking one element only, just short it. That's how like not it's not good, because when you like see its time complexity, you'll see it is not good. It's not so efficient in this time complexity, but it is efficient in case of its memory writes, like how many swaps it would do. In that case, it would be very efficient, but in case of the time complexity respect, it is not efficient. The method one is like efficient, but in that case also we have a like a constant in our range. In this case we have a constant, like, it can be bigger value. In that case time speed is more tedious also, be more tedious. So now it will be there, although the like the loop will continue to execute, but for now the array is shorted. For now array is shorted. Okay, so let's see. It's first of all I'll do the code and I'll explain the time complexity, but because with this explanation, I don't think time complexity could be explained, because it is a little bit of tedious work. So I'll go to the code, I'll code it, and I can come back and I'll explain the time complexity of it. Okay. So let's, I hope you understand it. Let's go to the like code. Yeah, let's go to the code and let's make a new like short, cyclic short method 1 file. Let's go to CodaGo. Let's go to the shorting one and let's make a new REPL here. The programming language Java, and let's make here cycle short method 2. Okay, create the REPL. Okay, create the REPL. We have the REPL now. Yeah, it is here. So let's, like the previous code, we have to make a function here. So let's make a function. It will be static void. Let's make the same name with the same name, cycle short, and it will be int main, and it will be arr. Here is the array we have, and what to do? Suppose we have like two variables. One is position variable, and other one is item variable. Okay. Now what we have to do? We have to take an outer loop, which is basically for int I equal to starting from 0 and up from n-1, because we don't have to bother about the last, because after that there is nothing. After that there is no sublist, like for this, like for this element, this is the sublist, but for this element we don't have a sublist, so we don't have to bother about the last one. It will be already taken care of. If the previous elements are shorted, that will be also be shorted. Okay, so int I equal to 0, I will be less than n-1, and it will be I plus plus. Okay, not n, we don't have n. Yes, that means this here dot length actually. Okay, now let's go to the, it's like in a side of the side of the list, that is the cat. Don't bother about that. Okay, so let's like you have to like pay attention to the code. Okay, so let's first of all take the position as I. To take the position as I, you just have to take the position as I. Now and item value will be the item equal to the what is the current position, like it will be error of I only, right? Error of I only. And then we have to take inner loop by checking the sublist, like the smaller values will incrementing the position. So I have to do int j equal to I plus 1. From that I plus, because we're taking after this sublist, after this, from this one to this one, we're checking this one to this one, the smallest values will compare while comparing to the item. Okay, so j equal to I plus 1, and we have to do j is greater than not greater than, with less than your dot length, because you have to go to the last index gth, and with j plus plus. Okay, and in here to check if here of j has some element which is less than the item value, less than the item value. If it does, then we will increment the position like the variable. Okay, it will increase the. After that, we'll check another condition. If the position, if the position is equal to I, that means the position value didn't change. It will stay as it is. It can't find any element which is in a sub list which is lesser than the current item. That means the item we chose it is already in the correct position. That means we just have to continue. We can't do anything else. We just have to continue. After that, we'll check. And another thing that is there any duplicate values? So we'll check. Here we'll check if the element is in its correct position, correct position, and okay. So here I just misspelled it. Position, and here checking is the element is like checking for duplicates, you can say duplicates. Okay, checking for duplicates here. So what I will check if like this current one, error of I, or the items value, you can say, make the items value is equal to the current position, like error of position, current value with the position. If it does, so we'll increase the position. You also done the same thing, right? It finds a duplicate, so we'll increase the position, right? So that particular thing we are doing here. Now after that, we'll swap. When we increased it, we'll just swap it, right? Not actually swap. We'll just put the two's value, here, like the items value in that position, and we'll change the item value to 2. That means we'll like swap between item and the current list, you can say. So what we have to do now? We have to just swap between, we can say here, swapping between error of position, current position, and item. So I have to do, we take the item here, temporary variable equal to item, and item equal to error of position, and we'll take error of position equal to item. Now here what do we do? We have done that, right? But in this case, after doing that, like after doing this, you can say after doing this, we will get the element as 22213 after the first step. So the 5 is missing, so we have to like do all the things, like revert for the rest of the cycle, do the same thing for the rest of the cycle. You can say do the same thing for the rest of the cycle, right? Until all the elements are there. Like here we don't have all the elements like this list, right? So it had to be present there, so we have to do reset again for the other cycles. We'll do this for the other cycles. So how to do that? We'll check for one condition. While ith index present index is not equal to position, if it is equal to, we'll break. In this case also, when 0 equal to position, ith index is equal to position, this is the ith index position, we break, right? We break. In this case also we will do the same. It's the last condition, you can say. We'll do the same. So it is same actually. Now also it will do the same. So it will be in this case also position will be equal to 0. Position will start from I actually. Okay, it will start from 0. Yeah, let's start from 0. And what it will do? It will just have to position will start from 0. Position start from I actually, I guess, not from 0. It actually starting from I, not from 0. From I. I'm going to 4 and k, because we already taken I and j, k equal to you can say the present one, like I plus 1, you can do which is equal to I plus 1 into I plus 1, and k is less than error dot length, and we are going to do k plus plus. And in the same case, we should have to give the same condition like what we given here. Just copy it and just paste it here. Okay, same code, just with here we have to pass k, right? After that we just have to just same code, so we have to paste the same code, like to check the checking for duplicates. We also have to check for duplicates. We'll check for duplicate value if item is the position. We check for duplicate value, and at the last we just have to like swap it. Okay, we just have to swap it. Okay, just have to swap the value. We don't have to take integer because we already like initialize it here. There we defined once, so we can't define it again. Basically we don't have to. So we have done this. Okay, so that is the code actually. We don't have to do anything else. Okay, so let's start. Let's make an array int arr, suppose equal to new int. We'll assign here, and we assign here 2 to 5 1 3. Suppose we have 2 2 5 1 and 3. It's random. This is not like the method one, right? Where we have a compact list, we can't do duplicates, but here we can actually. We do cycle short, and here passing error, right? And here we're printing the shorted array. Okay, so here we're doing and I equal to 0, I is less than error dot length and I is plus plus. Yeah. So now let's print it. System dot out dot print, yeah, dot print, and here we're passing error of I. Yeah. Now let's run it. I think it should work. Yeah, 2 2. Okay, it didn't work. Why? Just printed the same thing. What happens? Okay, we give an item here. We give an item. We need a temp value. Yeah, still mistake because we're swapping it, right? Explained already in the previous shorting videos how you can swap the values. So you didn't watch it, you can refer to that one. Yeah, here also we have to give temp only. Yeah, let's see. Yeah, it's 1 2 2 3. Now it's short. Okay, so that's the code. If you're finding it difficult, it's not that difficult. Take pen and paper and just write the steps by seeing this code. Just write the steps, debug it. Then you'll only understand how this code works. I know it is not that straightforward, but yeah, that is the code. So uh, that is the code. So that's it. Now we'll explain the time complexity. That is its time complexity is n square. Okay, its time complexity n square. How it will be n square is like the same. I'm explaining here only. Okay. So we have a while. We have a while loop, and in between we have another for. Okay, so it is n square, and for this outer loop, which is basically with three nested loops. So you'll say it should be n cube, right? Why is n square? But when we are doing the memory writes, when we are seeing it, it would reduce the time complexity. It would not, like, it would not execute. This steps will not execute in every time, like in every steps, it will not execute. That's why it is n square. Because we'll before we're checking this condition, and if the array is already shorted in the first step only, then this checks will not work. This loop will not work. That's why it is n square. That's why it's not n square. They're not n cube actually. Okay, that's the thing. And let's talk about this memory writes. because it is efficient for its memory. It is its advantages for its memory, right? So let's talk its memory. How many memory, right? We'll do okay, memory, right? Okay, memory, right, equal to, first of all, it's 0. So here memory is 0. Memory, right? Yeah. So here it is do one swapping. So here is memory, right? Memory, right, plus plus, and here we have to do memory, right, plus plus. Memory, right, plus plus. Yeah, right. And out of this thing, out of this uh, thing, like, look, we're just printing out the memory, right? Print memory, right? Yeah. Colon here and do it memory, right? Yeah. Let's run the code. Let's see how efficient it is. Increase the memory rate, how efficient it is. Yeah, it is memory rate of 4. See now how much efficient it is. If you also increase its value, like 8, 8, like 3 and 10, and now so you will run it and see its memory rate. In that case also it is sufficient. But for the many large large inputs, for that it is not, the time velocity is not good, but memory rate, index memory rate, it is great. So that's the whole explanation of the cyclic sort. I explained both the codes of the method 1 and method 2. So if you didn't understand the cyclic sort method 2, so you can comment it out. I'll explain again in another video, in a separate video, with examples, with like other questions. But for this video, is okay, it is done actually. So if you like the video, share it with your friends, share it in YouTube, like share it in Twitter, LinkedIn. And if you are learning in public, take a screenshot of the of this video and share it in, of course, Twitter and LinkedIn and Instagram, and with the hashtag learning with Ronak. And so that's it for today. See you in the next video. Bye bye.